Here, side by side, we see all of life, and life in its smallest package like a single cell. Like an intricate fractal, when we zoom in and out, the structure of life doesn't look that much different. What allows both this structure to survive is a thin layer of protection. The cell's membrane or the outer barrier selectively filters what goes in and out of the cells. For Earth, we have our atmosphere, the envelope of gases held around the planet by gravity that acts as the world's biggest membrane. Most of us takes atmosphere for granted and rarely think of what it's made of, how it moves or changes. We notice it when bad weather inconveniences us or appreciate it when we are outdoors. But it's been 5 billion years in the making, and that's how we and every other cells of life are able to survive. I am your host for today, Monica Laceda, and this is iScience. In today's episode, we are going to talk about our atmosphere, the Earth's atmosphere. The atmosphere seems like a peel of an orange. These thin layers of gas is so critical for life to exist, which is why it is very important for us to talk about. Without the atmosphere, none of the processes we'll study in the hydrosphere, lithosphere, and biosphere would function. To better study the progression, we can break up the atmosphere into vertical layers or spheres using different characteristics. We have 5 layers of the atmosphere: the troposphere, stratosphere, mesosphere, thermosphere, and the exosphere. Each layer of the atmosphere has its own unique characteristics, and they come from studying the atmosphere based on its temperature structure. Each layer has different starting temperature that decreases or increases as we move towards the outer space. Temperature can even affect the thickness of the layers. Join me as I will take you above the Earth atmosphere. Let's go to the first layer closest to the Earth, the troposphere.
The prefix tropo means change. The troposphere is heated by the Earth's surface. The Earth is like a giant heater, warming the air in the troposphere. The troposphere temperature decreases with elevation, so the air closest to the Earth is warmer, and the air farther from the Earth's surface is cooler. Troposphere. Nearly all the weather takes place in this layer. The troposphere contains about 75% of all the gases in the atmosphere. The troposphere holds 99% of the atmosphere's water vapor. The troposphere is between 5 and 8 miles thick, thinner at the poles, thicker at the equator. This is because temperature is warmer at the equator than the poles, and the warmer the air, the more it expands. The troposphere, it's the layer we live in.
Now let's step up to stratosphere.
The stratosphere, the second layer in the Earth's atmosphere. There's almost no weather in the stratosphere. Jet planes have a very smooth flight in the stratosphere. The ozone layer is located on the outer edge of the stratosphere. The ozone layer absorbs heat from the sun's ultraviolet rays. The ozone layer protects us from the ultraviolet radiation and acts like a giant heater, heating the stratosphere from above. The temperature here increases with elevation, ranging from -60 Fahrenheit to +5 Fahrenheit. The stratosphere is 22 miles thick, running from the tropopause, the outer edge of the troposphere, all the way to the mesosphere.
Let's go above the middle layer of the atmosphere, the mesosphere.
The mesosphere. Mesosphere lies above the stratosphere and below the thermosphere. It extends from the stratosphere to about 80 km above the surface of the Earth. In this layer, the temperature decreases with the height. As you go high around the mesosphere, the temperature decreases. The top of the mesosphere is the coldest part of the Earth's atmosphere. The temperature there is around -90 or -130 Fahrenheit. Weather balloons and jet planes can fly enough to reach the mesosphere. The orbits of satellites are above the mesosphere. The boundary between the layers in the mesosphere has special names. The boundary between the stratosphere and mesosphere is called the stratopause.
Let's go to the warmest layer, the thermosphere.
The thermosphere. The thermosphere is a layer of the Earth's atmosphere that is directly above the mesosphere and below the exosphere. It extends from about 90 km to 501,000 km above our planet. Solar activity strongly influences temperature in the thermosphere. The thermosphere is typically about 360 Fahrenheit hotter in the daytime than at night, and roughly 900 Fahrenheit hotter when the sun is active than the other times. The boundary between the thermosphere and the exosphere above is called the thermopause. At the bottom of the thermosphere is the mesopause, the boundary between the thermosphere and the mesosphere below. The Space Shuttle and the International Space Station both orbit Earth within the thermosphere. In the thermosphere and above, gas particles collide so frequently that the gases become somewhat separated based on the types of chemical elements they contain. Energetic ultraviolet and X-ray photons from the sun also break apart molecules in the thermosphere. Most of the X-ray and ultraviolet radiation from the sun is absorbed in the thermosphere. When the sun is very active and emits more high-energy radiation, the thermosphere gets hotter and expands or puff up. Because of this, the height of the top of the thermosphere or the thermopause varies. High-energy solar photons also tear electrons away from the gas particle in the thermosphere, creating electrically charged ions of atoms and molecules. Earth's ionosphere, composed of several regions of such ionized particles in the atmosphere, overlaps with and shares the same space with the electrically neutral thermosphere. Like the oceans, Earth's atmosphere has waves and tides within it. These waves and tides help move energy around within the atmosphere, including the thermosphere. Winds and the overall circulation of the thermosphere are largely driven by these tides and waves. Moving ions, dragged along by the collision with electrically neutral gases, produce powerful electrical current in some parts of the thermosphere. Finally, the aurora. The southern and northern lights primarily occur in the thermosphere. Charged particles like electrons, protons, and other ions from space collide with atoms and molecules in the thermosphere at high latitudes, exciting them into higher energy states. Those atoms and molecules shed with excess energy by emitting photons of light, which we see as colorful aurora displays.
And lastly, the farthest from the Earth, the exosphere.
The exosphere is the uppermost region of the Earth's atmosphere as it gradually fades into the vacuum of space. When the sun is active around the peak of the sunspot cycle, X-rays and ultraviolet radiation from the sun heat and puff off in the thermosphere, raising the altitude of the thermopause to heights around 1,000 km above the Earth's surface. When the sun is less active during the low point of the sunspot cycle, solar radiation is less intense and the thermopause recedes to within about 500 km of Earth's surface.
Thank you for joining me as we explore our atmosphere. See you again in our next episode here in iScience.